Hi everybody, this is your part 2 of lecture 2 and we are going to see histograms in this part. So what is the learning outcome? By the end of this lesson, you should be able to read, draw and interpret a histogram. Yeah. Okay, now you can see a chart here. The chart below shows the number of students from different nationalities. Okay. So what I want you to do is, I want you to type down what type of graph is this. Thank you. Okay. So I want you to tell me what type of graph is this. Yes, it's a bar graph. Bar graphs are used for qualitative and discrete quantitative data. You can clearly see that these graphs are not touching each other. Can you see? They're not overlapping each other. Yes, they're discrete. Yeah. These bar graphs are discrete. Yeah, they are not overlapping each other. While for continuous data, continuous quantitative data, we use a histogram. That is a main difference between bar graph and histogram. Okay. Okay, so that's what we're going to see, how we are going to represent a continuous quantitative data using histogram. So when data is continuous, we have already seen, we can summarize it in a grouped frequency table. Yes, you can class it and you can put the number of data in the corresponding class. Yeah, we have seen that. Continuous data like this can be represented in a graph, and that graph is known as histogram. However, before we construct a histogram, there are several values we need to find. Okay, there are three important things we need to find. And what are they? They are class boundaries, class width, and frequency density. Okay, so you have to find these three values before we construct a histogram. So let's see each of them one by one. So let's first see what is class boundary. Okay, let's see what is class boundary. How are we going to use it for histogram? Okay, let's see. Okay, so we have our grouped frequency table here. So that was the group frequency table. We're going to stick on to the same example, the cholesterol level of 30 adults. Okay. Now let's consider one of these class. I'm going to choose 5.5 to 5.9. Okay. How many adults have a cholesterol level between 5.5 and 5.9? Good. It is 6. Yes, there are 6 adults who have cholesterol level between 5.5 and 5.9. Okay. That's what you understand from the table. But this class could contain values as low as 5.45, because if you have an adult having a cholesterol level of 5.45, you're going to put that adult in this class, isn't it? You're going to put him in this class, because if you round 5.45, it's 5.5, isn't it? When you round 5.45, it's 5.5. So the adult is going to be in this category, in this class. Yes. So similarly, what is the maximum value this class can have? Good. The maximum value this class can have is 5.9499. That means if you round it to 1 decimal place, when you round it to this 1 decimal place, it becomes 5.9. Yes. So the maximum value it can take is 5.9499. And the minimum value could be as low as 9.45. Okay, so that means this class has a lower class boundary of 5.45. That means that is the lowest value it can take, and the upper class boundary is 5.95. That is the highest value it can take. This class can take. Okay, so that is how you create a class boundary. Okay. So when you have given a class, you have to create a class boundary, yeah? And this is how you're going to create it. Okay, let's see for the next one, okay? What is the lowest value this class can have? Good. 2.95. Yes? Okay. Yeah. And the highest value is 3.95. Similarly, 3.95 for this class, and the highest value it can take is 4.45. So you can apply this to all the classes in the table. Yeah, including the last one. Yeah. Okay, now I want you to tell me what is the lower class boundary for this class? What is the lowest value this class can have? And what is the highest value this class can have? And again, for the same for this. Good. That's right. Yes? Can you tell me? Good. It is 4.45 and 4.95. Yes, 4.995 and 5.45. Very good. What about this class? 5.95, 6.45, 6.45, 7.45. Okay, so that is how you create your class boundary, lower class boundary and upper class boundary. Okay, so we have seen what is class boundary. Now let's see what is class width. As the name says, it is a width of a class. It is the width of a class. So how can you find the width of a given class? Yeah. So how will you find the width of a given class? It is the notice bound, yeah, that I'll come to that. Yeah, it is the difference between the upper class boundary and the lower class boundary. Yeah, so 3.95 minus 2.95, 3.95 minus 2.95. Yes, so 3.95 minus 2.95. That is the class width of this class. Okay. Okay. One more important thing. Yeah, the boundaries always touch for adjacent classes. Look at that. It's overlapping. The upper class boundary of this class is the lower class boundary of this class. The upper class boundary of this class is the lower class boundary of this class. The upper class boundary of this class is the lower class boundary of this class, and so on. So it's overlapping, yes? Unlike the bar graph, here the boundaries overlap. Okay? Okay. So the difference between the upper class boundary and the lower class boundaries for this 3.95 minus 2.95 is 1. So the class width is 1. 4.45 minus 3.95 is 0.5. 4.95 minus 4.45, 0.5. 7.45 minus 6.45 is 1. So this is how you figure out the class width. You calculate the class width for a given class. Okay, now we have seen the class boundaries, we have seen the class width. Now let's see what is frequency density. The most important one. Yeah, what is it? What is frequency density? Okay, again, as the term says, frequency density. Yeah, frequency density means number of data occurring in a certain class. Yeah, within the class width. That is frequency density. Finally, to draw a histogram, this is very important because we need to compensate for the fact that the classes can vary in width. If you remember, when we were learning about the frequency table, grouped frequency table, I did mention that there is no given set rule to construct this grouped frequency table. Yeah, you can have your own class. Yeah, you can make your classes in your method. Yeah, in your style, in your own way. There is no set rule. I didn't mention that. But if that is the case, that means each of us will have different number of data in different classes. Yes. So how are we going to conclude or interpret this data? How? Because each of us will have different class table, frequency table, and you cannot interpret the data. How are we going to interpret the same way? Okay, so for this reason, we have to compensate for this, and this is why we take into calculation, because the class width is different for all of us. Yeah, we may draw a different frequency group frequency table, so we'll have different class widths for the classes. So to compensate for that, we take into account the frequency density. So this means we know that how many data are there in a certain class. How many data are there in a certain class. So we take into account something called frequency density. So frequency density is frequency divided by class width. So this will compensate for our method or whatever we choose to make our group frequency table. Yes. So we are all talking about the same data and we're going to represent it in different way probably, but frequency density will compensate for it. Okay, so how do you calculate frequency table? For each class, frequency, the number of data divided by the class width is your frequency density, okay? So 2 divided by 1 is 2, 2 divided by 0.5 is 4, 4 divided by 0.5 is 8, 8 divided by 0.5 is 16, 6 divided by 0.5 is 12, 3 divided by 0.5 is 6, and 5 divided by 1 is 5. So this will compensate for all that we did in last week. Yeah. Okay. So to draw a histogram, we use class boundaries, class widths, frequency density. So let's conclude that. Yeah. These three are the things we need to draw a histogram. And now let's see how we draw that. Yeah. How to construct a histogram. Before that, let me tell you something. A histogram is designed to show the true shape of the data by graphing the density of the data. In a histogram, on the x-axis, you have the upper class boundary. Yeah, you have the upper class boundary. So for example, here, the class boundaries you'll have, because you should include this also, otherwise you can't draw the table, isn't it? So you'll have the class boundaries, 2.95, 3.95. So you'll have the class boundaries. Yeah, and the distance between each class will give you class width. That's along the x-axis. The graph is with respect to the density of the data. So you will have the frequency. If you remember the Maxwell distribution, it's something like this. Yeah. So frequency density is on the y-axis. Okay, that's how you plot a graph. So class boundary on the x-axis, frequency density on the y-axis, and each class will give you the width. Yeah. Okay. Okay. So that's how it looks. Okay. That's how the histogram looks. So I have put 2.95 here. That is 2.95. This is 3.95. Then 3.95 to 4.45. Okay. 4.45 to this part is 4.95. Yeah. And so on. Okay. And on the y-axis is the density. Look at that. So you have 2, you have 4, yeah, you have 8, and so on. Okay. So now, very important thing, you know that on the x-axis, you have the class boundaries, you know that, and on the y-axis you have the frequency density, you know that. Now the most important thing is, what does this yellow region tell you? What does it tell you? What does it tell you? It tells you the area, what is there in this area, yeah? So let me tell you something, okay? What is the area of a rectangle? Good. Area of a rectangle is length into breadth. Area is length into breadth. Okay. So what is the length for this particular histogram? What is the length? For this just one box, yeah? What is the length? It is the frequency density here, yeah? So whatever frequency density it is here. So what is the frequency density here? 5, isn't it? Look at that. Go there, it is 5. So length is 5. And what is the breadth here? The class width, isn't it? Breadth is the class width. So what is the class width here? 1, isn't it? This distance is 1. So area is 1 times 5. What is this? 5. What is 5? What is 5? 5 divided by 1. 5 is the frequency. Yes? Okay, let me take another example. Okay, let me take this box. This box, next to it box. Yeah, that is better. Yeah. So what is the length here? L is, length is, oops. Okay, length is the height, isn't it? The frequency density. So the frequency density is 6. And what is the breadth here? The class width. Breadth is 0.5. So what is 0.5 times, what is the area then? 0.5 times 6 is 30. 30, and then you have this decimal, yeah? So it is 3. So it's correct, it's frequency. So what does area imply in a histogram? Area is nothing but the frequency, the number of data in that histogram. Area is the number of data. Area gives you the number of data in this particular box, yeah? If you want to find the area of the whole thing, for example, if you want to say, how many data are there below 5.95, then what do? You add all the areas. For each histogram, you add the areas, and then you'll get the number of data below 5.95. Okay? So each class is represented by a rectangle where the breadth can be given as the class width and the length can be given as the frequency density. And the area is nothing but, can you give me a formula for the histogram? Area is equal to, good. Area is equal to class width times frequency density, or this is equal to frequency. Perfect. Thank you, guys. Okay, so let's look at some key features of histogram. Okay, so if you are given a chart, if you're given a table, you can draw a histogram, yes, and each rectangle represents a class. Okay, each rectangle represents a class. We have seen that. There are no gaps. There are no gaps. Unlike the bar graph, there are no gaps between rectangles. And why do you think it is like that? Good, that's right, yeah. There are no gaps between the rectangles, yes. And the height, that is the overlap, yeah, the boundaries overlap. The height of each rectangle is the frequency density. The width of each rectangle is the class width. The area of the rectangle represents the frequency in the corresponding class. Okay. So these are the important points you should know about a histogram. Okay. So it helps you to interpret how many number of patients or adults in this case will have cholesterol level between 2.95 and 6.45. You can easily study from here. Yes, just by adding all the area. Area is nothing but frequency. So adding all the number of data. Okay. So a group frequency table and its histogram are equivalent to each other. So just as a histogram can be generated from a group frequency table, you can do the reverse. Yes? Okay, you can do the reverse. As so, a histogram can be reverse engineered to generate a group frequency table. From here to here, you can go back, isn't it? Please, can you try this? Yes? Okay. Now over to you. I have a few questions to ask. Please answer the question down here. Thank you. The histogram represents the distribution. I'm going to ask another question. It's a beautiful question which will help you understand whether you understood the topic, okay? The histogram represents the distribution of waiting times for patients seen at an outpatients department of a hospital. The data is based on a sample of 120 patients. Can you please fill this table? Use the histogram to complete the following corresponding group frequency table. Okay, can you please fill it on the side? Thank you very much. And I've given some hints, so please make use of it, yeah? Perfect. Over to you. Okay, that's all in histogram. Yes, the most important point in histogram is the area is nothing but the number of data in that class. Yes, or the frequency, number of data in that class or frequency. So area is nothing but frequency density times class width. Okay, so you have seen how to read, draw, and interpret a histogram. We'll do some more problems to help you understand how to draw the histogram and interpret the histogram, okay, in the seminar. Thank you guys. Bye for now.